Okay, transformations of exponential and logarithmic functions. Okay, we are transforming these functions similar to how we've been transforming every type of function we've dealt with so far. Okay, functions that we've been dealing with, we dealt with linear functions, absolute value functions, quadratic functions, higher or degree polynomial functions like x to the third, x to the fourth, and so on. Now we're going to apply this to our exponential and logarithmic functions. So it's the same process as all of our other transformations, okay? Nothing really different except the type of function we're transforming, okay? So let's start with just transforming our general exponential function. So let's look at just a plain old f of x equals, and let's have 4 to the x be our parent function in this case. So f of x equals 4 to the x. Okay, so if I want to translate it horizontally, again, horizontally is left and right. Again, remember, horizontal translations work backwards on how you think they would. Subtracting moves to the right, adding moves to the left. Okay, so, and it works inside the function. So f of x plus h, again, this is inside the function. Okay, it doesn't happen outside of the function, it's inside the function. And again, it works backwards. So if you're adding an h, that's going to move it to the left. If you're subtracting an h, that's going to move it to the right. Okay, so again, it happens inside the function. Okay, so if I take my f of x and let's translate it 3 units right. So let's go 3 to the right. So this happens inside the function in on the x. I would need to take f of x and subtract 3 from it to get my new function. So then my new g of x function would be, so I'm replacing my x with an x minus 3. So I replace this x with the x minus 3, so it'd be 4 to the x minus 3. Again, that's in my exponent. Again, my little x minus 3 is up in my exponent. That would move it 3 to the right. Again, it's inside the function. That's what f of x plus h means. Okay, right, so now vertical translation up and down. This happens outside of the function. I take the number and I add it to the outside. So I would take my function, my f of x, and I would either add or subtract my k on the outside. Again, adding k moves it up. Subtracting k moves it down. So if I want to move something 4 units down, I would need to take my f of x and subtract 4 off the end. F of x, subtract 4. So my f of x, so my new function would mean I would take my f of x function, which was 4 to the x, and subtract 4 off the end. Okay. So there is my translating 4 units down. Okay, my reflection. Okay, reflection involves putting a negative in it. If I put a negative inside the function, that's going to reflect it over the y-axis. Whereas if I put a negative outside my function, that's going to reflect it over the x-axis. Okay. So for example, a y-axis reflection of this, again, my original parent function, 4 to the x, would be 4 to the negative x, because I put a negative x into my function for x. Whereas a x-axis reflection, my new function, would be multiplying on the outside of my function. Negative times my f of x would be negative times 4 to the x. So this will reflect it in the y-axis. The y-axis will look like that. This will reflect it in the x-axis, will look like that. Okay. Horizontal stretch and shrink. Again, this works backwards, where we have to use the reciprocal idea. Okay. So if I want a stretch, again, vertical happens inside, so a times x. Okay. So if I want to shrink by 1/2, if I want to shrink it by 1/2, I need to multiply by 2. So I would need f of 2x. because again, that reciprocal, that whole reciprocal idea. So then my new function, my g of x, would be 4, instead of to the x, it would be to the 2x. So this 2 here is going to actually shrink it horizontally by a half. Okay. So if I want to, let's say, stretch by 3, again, I'd have to go f of 1/3 x, that whole reciprocal idea when horizontal. So stretching it by 1/3 would be 4 to the 1/3 x, or a lot of times you write it as x over 3. That's 1/3 x, or x over 3. So the dividing by 3 in there, or multiplying by 1/3, will actually stretch it by 3, the whole reciprocal idea. Again, because horizontal stuff works backwards. Okay, vertical stretch and strength is a little easier. You multiply on the outside of your function, a times f of x, and it works exactly how you think it would. If this a is greater than 1, it'll be a stretch. If the a is in between 0 and 1, it will be a shrink. Meaning if it's a fraction, you're going to go ahead and get a shrink. So now let's go ahead and let's shrink it vertically by a half. Shrink it vertically by a half. My new g of x would be 1/2 times 4 to the x. And if I want to just, let's say, stretch it by 5, my new function would be 5 times 4 to the x. Okay. All right, so let's go ahead and let's do some examples with these. Describe the transformation of f of x equals 1/2 x represented by g of x equals 1/2 x minus 4. Okay, so this is my parent function because I'm transforming this guy, there's my parent, okay, into this guy. Here's his child. So we want to figure out what's changed. This is 1/2 x. This is 1/2 x, but I'm subtracting 4 off the end. It's not subtracting 4 within the x. So since it's off the end, I know it's going to be vertical. Since it's subtracting 4, I know it's going to shift it down. So this is going to be a vertical translation 4 units down. Okay. So to get an idea here of the graph, my original, let's graph them both. We'll do some different colors. My original parent, again, when I put a 0 in, we'd get 1. When I put a 1 in, we'd get 1/2. Okay, so it's basically going to give me this kind of curve like this. It's going to be that whole decreasing exponential function curve right there. Okay, and then now we want to shift it down 4. So each of these points goes down 1, 2, 3, 4. Wait. And this one goes down 1, 2, 3, 4. So it's just shifting everything down 4. Okay. And again, I found these just by plotting points. I plot some points when I put in a 0. Anything to the 0 is 1. Put in a 1, we get 1/2. Put in a 2, you'd actually get 1/4. Because 1/2 to the second, 1/2 times 1/2 is 1/4. Okay, just plotting some points, or looking at the graph in your calculator, or looking at the graph using Desmos. Okay. Describe the transformation of f of x equals e to the x, represented by, so here's my parent function. Again, there's my parent. The transformation of this represented by this. Okay, well, I see my +2 on the end. I know that's going to go up 2. And then I've got a +3 inside here on the x. So this +3 here tells me, since it's up on the x, it's going to be a horizontal, so it's going to work backwards. So instead of to the right 3, this is going to go left 3. So it's going to be a what? Translation. And we'll just write translation up 2 and 3 to the left. Okay. And then again, we want to go ahead and sketch a graph of that. I'm not going to take time sketching a graph. I could graph each of them in my y equals e to the x, and then e to the x plus 3, arrow over, do the +2. Oh, my window's really messed up, so let's zoom. Come on, quit. Zoom 6. Okay, So there's my one and there's my other. Again, it shifted to the up 2 and to the left 3. Okay, good idea. All right, page. Okay. Describe the transformation of f represented by g, then graph each function. We're just going to describe the transformation. We're not going to actually graph them because, again, the graphing part's really pretty straightforward, especially with the graphing utility. Okay, so to describe the transformation. Okay, so again here, let's see, here's my parent function right there, 3 to the x. And now it's 3 to the 3x minus 5. Well, this minus 5 in here is going to shift it to the right 5, right? Because it's inside the function, so that's going to go to the right 5. And then this 3 out front here, that's a multiply by 3 inside the function. So that tells me that's going to be a horizontal stretch or shrink. Since it's horizontal, it works backwards. So since it's a 3, instead of a stretch, it would be a shrink, and by the reciprocal, by 1/3. So it's going to translate it to the right 5 and a horizontal shrink, not a stretch, by 1/3. Okay. So again, plot some points, get what those graphs look like. Okay. All right, on to the next one. So here's my parent function. F of x equals e to the negative x. So the negative x is already in the parent. Okay, and then what's changed between the parent and the child? Well, it's still e to the negative x, but there's a negative 1/8 there. Well, this is really doing two different things. The negative is going to do a reflection, and it's a negative out front. So a negative out front is a reflection in the x-axis. So we will have a reflection in the x-axis. Okay. And then this 1/8 again is out front, so that's going to be a vertical. And vertical works how you think it would. Since it's less than 1, it would be a vertical shrink by a factor of 1/8. By 1/8, so it's going to shrink everything down an eighth vertically up and down. Okay. All right, next let's go ahead and let's use these same rules. The rules are the exact same. Really what's going to change is our parent function. We're going to go ahead and use a log parent function. My function f of x equals, we'll go log base 10 of x. So log base 10 of x. So the horizontal translation and the f of x notation is exactly the same as here. So I'm not going to write those down. What I'm going to change instead is what the examples look like. So again, a horizontal translation happens inside the function. So in a log, again, in a log function, it happens inside the function. So if I wanted to shift it to the left 4, I would need to add 4 inside the function. So I'd have the log of x plus 4. Again, that's the log of x plus 4. This is not the log times x plus 4. This is the log base 10 of x plus 4. Okay. All right, so that's what a horizontal translation will look like. It's inside the log. Whereas opposed to a vertical translation where it happens on the outside, okay, again, if I wanted to translate this up 4, I would just have the log of x, and then I would have to add 4 onto the end. So this one here is going to go left 4. This one here is going to go up 4. Okay. Now again, a reflection, whether it happens inside or outside. Okay, inside the function is going to reflect it over the y-axis. Outside the function is going to reflect it in the x-axis. So in a log function, reflecting over the y-axis would be the log of negative x, because it happens inside on the x. A x-axis reflection is going to happen on the outside, the negative of the log of x. Okay. A horizontal stretch and shrink, again, remember that works inside the function, but it works backwards. So how that would look in a log function, if I want to stretch this by 4, let's do stretch by 4, I would need to multiply inside by a 1/4. So it would be the log of 1/4 x, which many a times we write it g of x equals the log of x over 4. we just multiply the 1/4 and the x. So that would be a stretch by 4. Okay, whereas a shrink would be the log of, let's say, 5x. That's going to shrink it by a 1/5. This guy right here is a shrink by 1/5. Okay. A vertical stretch and shrink happens outside the function. Okay, so how this looks in a log function is I would just multiply outside by something. Let's say 4 times log of x. That's going to stretch it vertically by 4. Or 2/3 log of x. That's going to shrink it by 2/3. Okay. All right, so let's go ahead and let's just do a few examples. Let's describe the transformation. Okay, so again, here's our parent function. We're going to describe this transformation. There's our parent. And let's see what's happening to my parent. I've got a negative inside the function. It's in on the x, so that's going to be a reflection. Since it's inside, it's going to be a reflection in the y-axis. And I've got a 1/2 inside, multiplying by a 1/2 inside. So that's going to be a horizontal stretch or shrink. Since horizontal works backwards, that's actually going to be a horizontal stretch by 2, the reciprocal of 1/2. Okay. Okay, now part B. Here's my parent function, log base 1/2 of x. So now let's see what's changing here. Well, we've got the 2 out front, so that tells me that's going to be a vertical stretch by 2. And then we've got the +4 on the inside, so that's going to be a horizontal translation. Again, horizontals work backwards. So that's going to be a horizontal translation 4 to the left. Okay. Again, we can sketch the graphs of those into our notes to get an idea on what they look like. You could graph them very quickly in Desmos or on your graphing calculator. Okay, so now let's go ahead and let's write a rule. These are different in that these ones gave us the rule. They gave us the parent, they gave us the rule for the child, I guess we could call it, and we needed to describe what happened. Here it's going the other way around. They give us the parent, but they want us to write the rule for the child. Okay, again, the trick here is go step by step. Don't do it all at once. Don't do it all at once. I've said this multiple times to us. We need to do it step by step. Do one thing at a time. So let the graph of G be a reflection in the x-axis. So we need an x-axis reflection. So what's an x-axis reflection look like? What does it do to the rule? Well, an x-axis reflection, x-axis, we flip it over, puts a negative out front of the function. So it'd be negative f of x. Well, my f of x here is this function right here. So I need to put a negative out in front of that function. So it'd be a negative, my f of x is 2 to the x. So a negative 2x is my rule for a reflection in the x-axis. So we just did this first part, a reflection in the x-axis. Now we need to follow by a translation 4 units right. Okay, so if we want to go 4 to the right, again, I'm just going to write what I'm going to do first. I need to take my function. If I'm going to the right, that's horizontal, so that works backwards. So I need to take x minus 4 and put it in my function. So I take my function here. This is my new function I'm working with. And I want to put an x minus 4 in there for my x. So I replace my x with an x minus 4. So then it would be still have my negative and my base is still 2. But now instead of x, I'd have x minus 4. So I did a reflection in the x-axis, got this. And now I want to take that and translate it 4 to the right, and I get that. And that's my new rule for g, so this is my g function. G of x equals that right there. Negative 2x minus 4. Again, this negative 2 is going to reflect it in the x-axis. This x minus 4 is going to translate it 4 to the right. Okay. Example 6. Let the graph of g be a translation 2 units up, followed by a vertical stretch by a factor of 2 of the graph of, okay, so here's my parent right there. There's my parent function right there. Again, don't do it all at once. Let's do piece by piece. So I want to translate it 2 units up. So if I want to translate it 2 up, that means I take my function and I add 2 onto the end. So I want to take my function. Well, my function is this, log base 1/3 of x, and add 2 onto the way end like that. So there, I got my 2 units up. This is my new function right here. Again, this would be f of x, or in this case, g of x. Okay, but now we want to follow by a vertical stretch by a factor of 2. So vertical stretch by a factor of 2. So we want vertical stretch by 2. So to do that, I take my function and multiply 2 on the outside of it. 2 times my entire function. Well, again, my entire function is this guy up here now. So I want to take 2 times that whole function. So 2 times this whole thing. Not 2 times the first thing, 2 times the whole thing. So 2 times this thing. Okay, so I have 2 times that. Again, this is 2 terms, so I could distribute this 2 in. So it'd be 2 log 1/3 x, and 2 times 2 is 4. So there is my new function. So that would be my new g of x function, is that guy. It says write a rule for g, so that's my g function right there. Okay, 2 log base 1/3 of x plus 4. Okay. A very common mistake is just to throw the 2 out front and forget it's applying to the whole function. So it does apply to this other 2 and back, because we, again, do one thing at a time. Don't do it all at once. Okay. All right. Now I want you to go ahead and do some practice on these transformations. Again, the rules are the exact same as the rules we've been dealing with since September. Okay. Only thing that's changed is the function we're applying them to. Good luck.